This will be our third video on the role of artificial intelligence for project managers in the photovoltaic sector. Commissioning doesn't end with grid connection. To ensure long-term profitability, it's essential to validate plant performance, detect potential deviations, and prepare for smart operation and maintenance from day one. This is where artificial intelligence enables a smooth transition to O&M and a rigorous evaluation of what was built. In performance validation, as built versus as designed first, AI automatically compares the actual performance measured in the field as built with the estimated performance in the design as designed. This includes an accurate calculation of the PR, performance ratio, adjusted for real-world conditions, irradiance, temperature, etc., and allows for technical justification of the quality of the EPC. Early detection of performance anomalies with data analysis, for example, allows for identifying underperforming strings, diagnosing inverter failures, and premature degradation, detecting thermal hotspots and unjustified losses. This monitoring allows for corrective decisions before problems impact monthly production or the PPA's SLA. The basis for predictive maintenance, PDM, allows all data collected during commissioning to feed predictive maintenance algorithms. This allows for anticipating failures, defining optimal maintenance windows, and reducing unnecessary corrective intervention. AI-enriched digital twins are the main pillar of AI in O&M. Digital twins provide a living model of the plant, synchronized with real-world data. With this model, among other things, the following can be achieved: simulate failures, verify the impact of configuration changes, and optimize strategies without jeopardizing real-world operations. The example on the right shows how this twin identifies strings with poor performance, sector A3, inverters with reduced efficiency, and substations with associated alerts. Having an actual versus predicted performance dashboard is essential to understand, for example, the weekly evolution of actual versus estimated PR. It detects deviations and associates them with specific causes. And it classifies anomalies by impact, as seen in the red box. For example, a string with 8% less production or an inverter 2.5% less efficient than the rest. Measurable results are necessary, and applying AI in this phase generates real benefits such as more than 1.8% in annual production, less than 12% in operational failures, more than 22% in O&M planning efficiency, less than 8% in operating costs. These percentages, applied to plants with tens of megawatts, translate into hundreds of thousands of euros in annual improvements. As a PM, this phase allows you to properly close the project cycle and ensure that what is delivered meets the contracted requirements. It also paves the way for smart, optimized, and real-time monitored operations. Now, let's answer a key question for any project manager or finance manager. Is it really worth investing in AI solutions for photovoltaic projects? To answer this question, let's compare traditional design with AI-powered design and quantify the return on investment. Let review the key criteria step by step. Energy prediction accuracy. AI enables more accurate P50/P90 estimates, which translates into more than 2.5% improvement in expected production. Design time. What previously took days or weeks is now reduced by 70% thanks to automation and parallel simulations. LCOE optimization. With AI, design is not limited to a few iterations, but explores hundreds of configurations. Result: an LCOE reduction of between less than 3 and 7% through an optimized design alone. For risk detection, while traditional methods rely on experience, AI enables proactive, data-driven detection with improvements of over 85% in error anticipation. These changes translate into an average LCOE reduction of 5.2%, a 65% reduction in design time, and an ROI recovered in 9 to 14 months, well below the typical project execution time. But where does the return really lie? Improved energy production. Thanks to more efficient layouts and better component selection. Reduced costs and timelines. AI eliminates rework, improves planning, and reduces construction and documentation costs. Risk minimization. Fewer errors, fewer contractual penalties, and greater regulatory compliance. Improved bankability. Investors have greater confidence in projects with accurate simulations and digital traceability. Here's a breakdown of the impact of AI on LCOE by component. Optimized design has the greatest impact, followed by component selection and failure reduction. Even predictive maintenance and optimized operation contribute incrementally. Everything adds up to a more competitive LCOE and a more attractive IRR for investors. The data confirms it. Applying AI is not only technically feasible, but also financially and strategically profitable. So far, we've seen the benefits, the platforms, and the ROI. But no profound technological change is free from friction. And when implementing AI in photovoltaic projects, there are technical, organizational, and cultural challenges that we must consider for a sustainable and efficient transition. Data quality and availability have a high impact. AI is only as good as the data it's fed. If project data is incomplete, inconsistent, or poorly standardized, the models will be inefficient or biased. It's essential to have data capture, cleansing, and normalization protocols in place from the start of the project. Integration with existing tools has a medium impact. Many teams still use legacy software, Excel, AutoCAD without BIM, closed SCADA systems, etc. Integrating AI with these tools may require API development or partial migrations. A gradual, non-disruptive transition must be planned. The cost of implementation and talent has a medium impact. The initial investment is not just software. It also requires consideration of cloud licenses, processing hardware, edge, drones, sensors, and, above all, training of the technical team to interpret and use AI. It pays for itself quickly, but must be included in the initial strategy and budget. Model interpretability, black box, has a high impact. Many AI models, especially those based on deep learning, operate as black boxes, producing results, but not explaining how they arrive at them. This can generate mistrust or regulatory issues. Therefore, it is key to opt for solutions that include model explainability or dashboards with traceability. Data cybersecurity has a high impact. AI involves handling large volumes of sensitive data, IV curves, real-time energy production, technical configurations. It is vital to implement encryption, backups, access control, and compliance with regulations such as GDPR or NEIS2. Standardization and regulations have a medium impact. As of this video, there is no specific technical standard governing the use of AI in photovoltaic projects. This creates legal and technical uncertainty. It is recommended to align with ISO 42001, AI Lifecycle Management, and frameworks such as IEC 63235 or IEC 61850 when working with Edge and SCADA. Change management has a high impact. Many teams are accustomed to working with their usual methods and tools. AI can be seen as a threat, when in reality it is a help. The key is ongoing training, support during adoption, and clear communication about the real benefits. With all this, we can make the following final strategic recommendations. Implement AI in phases, invest in ongoing training, build reliable technology partnerships, establish data governance policies, and continuously monitor ROI. By addressing these challenges, we can move forward safely, profitably, and progressively. Below, we'll look at how all of this fits into a complete smart PV project management cycle and what concrete steps you can take as a PM. Throughout these 3 videos, we've covered all the phases of a photovoltaic project's lifecycle, showing how AI can add real technical, economic, and operational value. Now, we're going to integrate everything we've learned into a comprehensive vision of the future and concrete action for you as project managers. The complete cycle with AI as the central engine. At the center, the AI engine drives each phase of the project, development, with optimized site and resource analysis. Design, with automatically generated layouts to maximize production. Engineering, with AI-generated technical documentation. Construction, with autonomous monitoring and progress dashboards. Commissioning, with intelligent validation and quality.O&M, with a digital twin that evolves and learns with data. This structure isn't theoretical. It is the basis of the most advanced digital systems already being deployed in utility-scale projects. AI cannot operate in silos. To achieve this, we need interoperability between design, construction, and operation tools. Unified platforms that add consistent and synchronized data. And digital twins that faithfully represent the actual behavior of the plant. This is the architecture recommended by standards such as ISO 23247 and the IEC 61850 framework with a digital twin extension. If implemented correctly, the results are overwhelming, achieving a reduction of between 5 and 8% in LCOE, a 30% reduction in time, a 15% increase in annual production, a 20% reduction in construction and O&M costs, and a 40% increase in estimated IR. In the photovoltaic sector, AI is not only a competitive advantage, but a strategic necessity to stay relevant. And if we take a look at what AI and photovoltaics can expect in the coming years: total autonomy, plants designed and managed without direct human intervention. Generative AI, not only for design, but also for financial planning, ESG, and legal documentation. Real-time, dynamic decisions based on up-to-the-second data. This isn't a futuristic scenario. There are already projects underway with these three pillars. What can project managers do? Identify priority use cases. Where do you have bottlenecks or high-risk areas? Start pilots with AI solutions. Small projects that validate the approach. Develop a data strategy. Without clean data, no AI can work. Train project teams. Just having the tool isn't enough. You have to know how to use it. AI doesn't replace human judgment in photovoltaic projects. It enhances it exponentially. You, as project managers, are responsible for integrating this intelligence into your teams and decisions. I hope you enjoyed this video series and that the comments reflected in these videos will help you in your daily life. Send me a private message on LinkedIn, and I'd be happy to receive your constructive feedback for future videos. Thank you very much, and best regards.